This is section 6.2, part D, combining normal random variables. So far, we have concentrated on finding rules for means and variances of random variables. If a random variable is normally distributed, we use its mean and standard deviation to compute probability. Any sum or difference of independent normal random variables is also normally distributed. The mean and standard deviation of the resulting normal distribution can be found using the appropriate rules for mean and variance. So we are going to be doing a 4-step problem. Mr. Starnes likes sugar in his hot tea. From experience, he needs between 8.5 and 9 grams of sugar in a cup of tea for the drink to taste right. While making his tea one morning, Mr. Starnes adds 4 randomly selected packets of sugar. Suppose that the amount of sugar in these packets follow a normal distribution with a mean of 2.17 grams and a standard deviation of 0.08 grams. Find the probability that Mr. Starnes' tea tastes right. Now remember, with a 4-step process, you're first going to start with the state. So we're trying to see what our question is going to be. So in this case, our state could be, what's the probability that Mr. Starnes' tea tastes right? Next, you need to come up with your plan. So for our plan, we can let x equal the amount of sugar in a randomly selected packet. So then x of 1 is the amount of sugar in packet 1, x of 2 is the amount of sugar in packet 2, x of 3 is the amount of sugar in packet 3, and x of 4 is the amount of sugar in packet 4. Each of these random variables has a normal distribution of the amount of sugar that Mr. Starnes is going to put in his tea. So to find the total amount of sugar he's going to put in, we're just going to add those 4 random variables. And our goal is to find the probability that T, the total amount of sugar, is between 8.5 and 9 grams. Next is our do. This is where we're going to do all of our calculations. So the random variable T is the sum of 4 independent normal random variables. So T follows a normal distribution. Remember, to find that total, since we're just adding the packets together, you would just add their means together. Each packet has a mean of 2.17 grams. So if we add them together, we're going to get our mean for the total amount of sugar to be 8.68 grams. Now to find our standard deviation, you first have to find the variance. And to find the variance, you're going to take the standard deviation of each packet and you're going to square them and then add them together. Now, it was told to you that each packet has a standard deviation of 0.08 grams. So you're going to do 0.08 squared 4 times because there are 4 packets, and you'll get a variance of 0.0256. Remember, to find that standard deviation, you will then just take the square root, and you're going to get a standard deviation of 1.6. Once you know the mean and standard deviation for the total amount of sugar from the 4 packets, we can then try to determine the probability. Now, to find probability, we can find the area. Because this is standardized, we said it was normal, we can standardize it and use table A. Remember, to standardize it, that means you're going to find the z value, and z is equal to x minus mu over sigma. So we are going to have to standardize it for 8.5 and for 9 because we want to find the probability that is between those 2 values. So we'll do 8.5 minus that 8.68 divided by the standard deviation of 0.16, and that will give you a z-score of negative 1.13. We'll do the same thing with our x value of 9, and you'll get a z value of 2. Now you will go to your table A, you will look up the z value of negative 1.13, and you will see that it has an area of 0.1292. You will look up the z value of 2, and you will see that it has an area of 9.72. Remember, when we are doing these, if I have a standard deviation of 2, that would be over here. A standard deviation of negative 1.13 would be over here. When you find the when you standardize it and get the z-score, and then you look up the table information, the table's telling you the area to the left of it. So the area to the left of a z-score of negative 1.13 is about 13%. The area to the left of z equals 2 will be about 97%. but we just want to find this part in the middle. So you will subtract those two different areas, and you'll find the part in the middle is 0.8480. So for our conclusion, we can say there's about an 85% chance that Mr. Starnes' tea will taste right. Let's look at another example. Again, this will be another 4-step problem. The diameter C of a randomly selected large drink cup at a fast food restaurant follows a normal distribution with a mean of 3.96 inches and a standard deviation of 0.01 inches. The diameter L of the lid for a large cup is also normally distributed with a mean of 3.98 and a standard deviation of 0.02. For the lid to fit on a cup, the value of L must be bigger than the value of C, so the diameter of the lid must be larger than the diameter of the cup, but not more than 0.06 inches more. Find the probability that a randomly selected large lid will fit a randomly selected large cup drink. So again, this is a 4-step problem. You're going to start with your state and determine what we're trying to solve. So for our state, what's the probability the randomly selected large lid will fit a randomly chosen large drink cup? Next, we're going to come up with our plan. So for our plan, we are going to define the random variables. We're finding the difference of the diameter of the large lid minus the diameter of the large cup. And our goal is for the difference to be between 0 and 0.6. So they're the same size, and the largest that lid can be is 0.06 inches larger. So that's when we get to the do. Remember, on the do, we need to find the difference first. And if you're finding the difference of two random variables, you're just going to find the difference of their means. So the mean of our lids is 3.98 inches. The mean for the cups is 3.96, so the difference will be 0.02. To be able to find that standard deviation, you first have to find the variance. Even though we are finding the difference, when you're finding the variance, you will still add those values together. So we're going to take the standard deviation of the lid squared plus the standard deviation of the cups squared. You're going to add those two values together, and that will give you the variance for the cup to lid to the cup, the difference. To find the standard deviation, you will take the square root of both sides, and we will get a square root of 0.0224. Now this is where we can standardize our values and find the probabilities. Again, to do this, you are going to find the z value, and then you will look up our z values in table A. So you're going to find a z value when x is 0, or your difference is 0, and you're going to find a z value when our difference is 0.06. For both of them, you're going to do the difference minus the mean over the standard deviation. Now our two z scores we get are going to be negative 0.89 and 1.79. Remember, when you look this up on the table, this is going to tell you the area to the left of those. So the area to the left of negative 0.89 is 0.1867, or about 19%. And the area to the left of our z value of 1.79 is 0.96, or about 96%. So to find this part in the middle, we are just going to subtract those two areas, and we are going to get an area between the two of 0.7766. So for our conclusion, we can say there's about a 78% chance that a randomly selected large lid will fit a randomly chosen large cup at this fast food restaurant. So roughly 22% of the time, the lids won't fit.